All right, guys, go ahead and try and do the matching in your groups. So pause your video, and then once you're done, you'll come check back here. So when we have our base, we check to see if it is growth or decay. So looking here, our base is 3/7, which is less than 1, but greater than 0. So this is an exponential decay. If we look at our A value, this tells us if it's a reflection over the x-axis or no reflection. So we have a positive A value, no reflection. So if we look, decay is getting closer to that horizontal asymptote. So A would best fit number 3. For B, it is going to be, our B is 4, which is greater than 1, which tells us exponential growth. So it's going to grow away. Our A value is positive, again, so no reflection. So if we look, number 4 is our best fit here. Now for C, again, our B is 3, which means it is exponential growth. However, this time our A value is -1 or -3, so it's a reflection over the x-axis. So if non-reflected growth looks like this, if we're reflecting it, it will be getting further and further away from the horizontal asymptote, but under it. So our growth, a reflected growth, will be C. By process of elimination, our first one will be D, but let's talk about it. If I have a negative exponent, that means we need to reciprocate the base. So our base now becomes 1/4 to the power of x. This shows us that we have a base of 1/4, which is greater than 0 but less than 1, so it's decay. Remember, decay normally looks like this. However, we have a negative A value, which means it is reflected. And our graph will look like this. All right, so some key characteristics that we're going to fill in is kind of just what we go through. So A values tell us if it is reflecting or not reflecting. So A represents whether it's reflecting or not reflecting, but it's also the initial amount. Our B represents the common ratio, so what we're multiplying by, and our base. So when your B is greater than 0, so you can't have bases that are 1, and your base has to be greater than 0, otherwise it's not continuous. So when your base is greater than 1, it's exponential growth. When your base is greater than 0 or less than 1, it's exponential decay. And then our increasing and decreasing. So exponential functions are always increasing or always decreasing. They will never switch from one to the other, so they have no relative maxima or minima. All right, now talking about concavity again. So they're either always concave up or concave down. They will never switch concavity, so they have no points of inflection. And then our end behavior for exponentials in general form, as input values increase or decrease without bound, the output values will increase or decrease without bound. They will approach 0. So basically, one of your limit statements will be going to your horizontal asymptote, whereas the other will be going to infinity or negative infinity. All right, so looking here, I'm going to go through step by step how we graph one together, and that is weird because there's supposed to be a graph here, so draw it in. So now, our first step is we're going to look. Our initial value is 4, so our A value is positive 4. The base here is 3, and the K value on the end tells us our horizontal asymptote. So we have a horizontal asymptote at y equals -1. So let's just go ahead and draw that in. Now, if I have a base of 3, we know that this is growth because it's greater than 1. Our A is 4, so there's no reflection. So our graph will look like this. Now, if we need 2 points to graph, we have to pick some smart points here. So I would like my exponent to equal 0 because anything to the 0 power is 1. So I think x plus 2, how do I make that become 0? We'll plug in -2. So we say k of -2 equals 4 times 3 to -2 plus 2 minus 1. So a point we have on the graph k of x is -2, 3. And again, we know the shape, we just want to have some exact points. Another point we could use is, well, anything to the power of 1 is pretty easy to figure out. So what number plus 2 is 1? We'll do -1. So k of -1 is 11. So if we look, our graph is exponential growth with no reflection, so it will look like this. If we want to know our domain, well, all real x values work here, whereas our range will be from -1 to infinity. Now, if we're writing our end behavior as x decreases without bound, that means we're looking at the left side of our graph. So we're going to say the limit of g of x as x goes to -infinity. Well, what y value is that approaching? In this situation, it's approaching our horizontal asymptote of -1. If it's asking us the end behavior as x increases without bound, that's asking as x goes to infinity. So if we write our limit statement there, the limit of g of x as x goes to infinity, well, it's going up and on forever, so it goes to infinity. Something else to note here is we're going to be talking about whether the rate of change is increasing or decreasing. So my rate of change of g of x is increasing. Now think about, why would our rate of change of g of x be increasing? Because g of x is concave up. Now what I want you to do is attempt number 2 on your own. So go ahead and pause the video, and I will have this one completed for you. So pause your video. All right, I'm assuming that you completed the question, so go ahead and watch through. A negative a value means it's reflected. A b value greater than 1 means it's growth. So if normal growth looks like this, reflected growth will look like this. We have a k value of 3, so our horizontal asymptote is at y equals 3. Now we're going to plug our values in. We want an exponent of 0, so we plug in 0. So h of 0 is 1, and then we love an exponent of 1. And then h of 1 is negative 7. So if we think about it, this is growth, and it was reflected, so it should look like this. Our domain is all real x values, so negative infinity to infinity, whereas our range is negative infinity and then approaching our horizontal asymptote of 3. So because it's negative infinity to 3, we know it is a reflection. Now go ahead, make sure you attempted your end behavior as x decreases without bound. So as x goes to negative infinity, it's getting closer and closer to our horizontal asymptote of 3. Whereas as x increases without bound, so as x approaches infinity, it's going to negative infinity because it's going down. All right, go ahead and attempt number 3 on your own. Once you got it, you'll put a star by it and compare with your group to see if they got the same thing. You'll then open up the second video for our practice of writing equations.